So what I'm going to do is provide maybe a little bit of introduction, and I call this Doug Hooton, a legacy of support on the use of slag cement. He has really done a lot of the seminal research over the years that has brought strength and durability and various applications to the fore in using slag cement. Canada actually got a jump start on the United States with the opening of the Hamilton plant. And Doug was nearby in Toronto, and he was able to grab this relatively new material and do a whole bunch of research over the years. And I'm going to be outlining some of the things that have been really important that he's done that are part of our sort of slag lexicon these days. Doug himself got his PhD from the University of Toronto in 1981. Huh?
McMaster University.
Oh, I'm sorry. I apologize. I apologize. From McMaster University in 1981. He was a research engineer at Ontario Hydro from 81 to 86, but then became a professor at University of Toronto for about 35 years, and of course now he's has emeritus status, and he also has his own consulting firm, Concrete Durability Associates. So he's spent a lot of time and done a lot of research in our industry. His PhD thesis, I was trying to dig up some old things, and I actually was able to, I had never downloaded it before, but I actually downloaded all, I think it's 256 pages or something of it, and I'm looking, if you look at this, you can see this is hand typed, this is not a word processor. IBM Selectric, and I just can't, I remember doing some of that because I was old enough before computers, but I can't imagine doing 256 pages, and if you make a mistake, you got to redo the page. That's got to be a real pain in the butt. But his thesis was on pelletized slag cement, hydraulic potential, and autoclave reactivity. And this focused on development of a test method to quantify the degree of vitrification achieved in blast furnace slag, and evaluation of various test methods, new and older, for potential use in commercial quality control. So slag is kind of just getting started as a new material. It's going to be expanding significantly. So this was kind of really good research at the beginning of, near the beginning of all this. The study, it also studied the incorporation of slag cement in autoclave binders having a wide range of compositions in the ternary system containing slag, Portland cement, and ground quartz or silica flour. And then finally, the effects of variations in the physical and chemical properties of slag cement on autoclave reactivity. So that was the 256 pages. There were several technical papers that resulted from this, of course. The scope of Doug's research over the many years includes things like concrete durability and service life, various properties of Portland, SCMs, all SCMs, not just slag, admixtures, structures and bridges, and especially durability, waste material utilization, alkali aggregate reactions, sulfate resistance, de-icer salt scaling resistance, properties of ancient concrete materials. I think some of those materials were some of the original buildings that were built with slag in Toronto. Those are now ancient. So, and performance standards, specifications for concrete. He's received many honors. Some of the highlights of this are the Bryant Mather Award from ASTM. He's honorary member of RILEM and ACI, and he was awarded the Research Chair in Concrete Durability and Sustainability from Natural Sciences Engineering Research Council of Canada and the Cement Association of Canada, just to mention very few of those awards. Now let's get into the meat of my presentation here, talk a little bit about Doug's work with slag cement. I went through, Doug has kind of a curriculum vitae on his website, so I kind of went through that, And I did a quick look and found out that probably around 42 out of the 226 items in his scholarly and creative works had to do with slag of one way or another. His very first cited work was glass content determination and strength development predictions for vitrified blast furnace slag. And this, I believe, was probably an offshoot of his thesis. It was part of ACI SP 79 in 1983, and in this he established that XRD was the most reliable method for determination of vitrification, degree of vitrification, and it also established that the strength of slag and Portland cement mortars was related to the chemical composition, fineness, and degree of vitrification. So what I thought, because there's so many different works that Doug has done, I went back to, he is chair right now of ACI 233, and I was trying to look for some history. Do you know when 233 was formed as a committee? Were you on the original, were you on it when it was formed?
83, 84.
Yeah, you probably were one of the original members on it. And if nothing else, you're a very long-standing member of the committee. And I looked at that, and there are 16 references in that report, which is our current report for ACI 233. And what I thought I'd do is, since those were the ones that were cited, is take a quick look at each of those and see the different areas that Doug had a hand in, and there are many. For instance, on slag characteristics, there was a paper called Pelletized Slag Cement Autoclave Reactivity, and it confirmed that because of the complexity of the reacting system, the best way to evaluate slag cement is not necessarily by looking at the materials that it's composed of and whatnot, but really through direct testing of workability, strength characteristics, and durability. Then we get into some of the durability aspects of slag cement. For instance, sulfate resistance. Doug had a paper called Sulfate Resistance of a Canadian Slag Cement. This is one of the references in ACI 233. And it was published in the ACI Materials Journal. Here they did over 1,000 cylinders cast from 8 concrete mixes, looked at 45, 65, and 72% slag, and basically concluded that 50% slag replacement for Portland generally can provide a better performance than a high sulfate resistant cement, regardless of C3A content. So you could use a type 1 cement with 50% slag and get better performance. Also, Doug's done a lot of work with ternary mixtures of various types, ternary with slag and silica fume, slag and fly ash. Generally, most of them are with some type of slag in there. His paper, Some Characteristics of High-Strength Structural Concrete, summarized one of these ancient concrete structures, the 68-story Scotia Plaza building, and it had a ternary mixture with 28% slag, 7.5% silica fume, and there was some concern that there was some strength retrogression in silica fume concrete, so he did some testing over 7 years to ensure that was not happening. Another paper was Canadian use of ground granulated blast furnace slag as an SCM for enhanced performance of concrete. This particular paper kind of summarized a lot of the benefits of slag cement, strength enhancement, workability, durability enhancements, and also noted that slag had become, at that point in time, which was 2000, the predominant SCM in Ontario. The durability, another paper is durability of ternary blend concrete with silica fume and blast furnace slag. This was a series of laboratory and outdoor exposure site studies which showed how ternary mixtures with slag cement and silica fume significantly improved rapid chloride permeability and ASR resistance. And this used large-scale cast-in-place slabs and simultaneous lab specimens, and actually looked at salt scaling too. And we'll get into salt scaling a little more. Doug's done quite a bit of work on salt scaling. Even delayed Ettringite formation, there was a paper called The Effect of Pozzolans and Slag on the Expansion of Mortars Cured at Elevated Temperatures, microstructural and microchemical investigations. And basically what Doug showed here was for slag, metakaolin, and fly ash, you could generally, using the right materials and the right amounts, generally prevent DEF from occurring in heat-cured mortars. Even outside the box of concrete, he had a paper called Microstructural and Chemical Investigations of Cement Paste Backfills, and this looked at a particular mine, the Kidd Mine in northern Ontario, where they used 90% slag, 10% Portland to stabilize the mine tailings. Then here we get into a couple of papers on de-icer salt scaling resistance. There's sometimes been a knock on slag or even fly ash on de-icer salt scaling, being on the commercial side of going into new markets, and they don't finish it correctly. They leave it, they trowel in the bleed water, and then you get salt scaling. And what this actually showed is in a controlled environment, it reported on 12 years of field performance on 6 slag and fly ash SCM mixtures, and between 25 and 50% slag, 15% fly ash, and a ternary mixture. And it looked at cured and tested specimens with ASTM 672 and found that this was a very, very severe test compared when you allow the slag just to kind of cure out for about 4 months and then put it through the testing regimen. The test was probably designed for normal Portland cement with much quicker cure and strength gain times. And a follow-on study, de-icing salt scaling resistance, incorporated SCM's laboratory and field test data in 2008, basically showed that there was a new, I guess it was relatively new at the time, called the BNQ test, which is a salt scaling test for Quebec that was developed. That is not the ASTM C672 test that is very harsh, and it was that particular study found that the BNQ test did a much better job of comparisons with the field studies as opposed to ASTM 672, which was a very, very harsh test. On drying shrinkage, this is one of my favorite papers that he ever wrote because I helped him a little bit on it. I'm just kidding. The effect of ground granulated blast furnace slag on drying shrinkage of concrete or critical review. This particular paper, there were some concerns that slag was had higher shrinkage than regular Portland cement mixtures. The Slag Cement Association at the time, and I was part of it then, asked Doug to do a study on this, and he established that really the only parameter of a slag mixture design that had a significant influence on the drying shrinkage was the total aggregate volume. The slag itself, whether it's in a blended cement or added at the ready mix plant, didn't have an effect on drying shrinkage. ASR mitigation, another very large area and important area of research. This particular study is kind of a culmination, a 20-year field evaluation of ASR mitigation. And this was in the ACI Materials Journal, reported 20-year performance of ASR field exposure samples placed in 1991. And among the many results and conclusions of the study, he found that there were actually 3 concretes that showed no evidence whatsoever of cracking with a deleterious aggregate. 2 were with 50% slag replacement, and a ternary mixture with 25% slag and 3.8% silica fume. I'm just about at the end. these are, all of these papers are part of ACI 233, and they're representative of the vast amount of research that Doug has performed over the years. With the Slag Cement Association, when I was there, we brought Doug in and asked him to help us get the word out on slag, because it was a bit more mature in Canada, but in the United States it was still, other than maybe in sort of the Baltimore, Washington, Mid-Atlantic area, it was still pretty new material. So we had Doug do a series of seminars with concrete decision makers, engineers, producers, and he helped get the word out. This was really critical to establishing a baseline of education on slag in the areas that slag was available. So that was extremely helpful, besides just being able to talk to Doug about various aspects of slag, which our Slag Cement Association Technical Committee did from time to time. The other thing we did is initiate some research with Doug. I meant already that bottom item, I already mentioned the shrinkage study, but there were some other de-icer salt scaling studies beyond the ones I've mentioned already. The Slag Cement Association kind of pushed these through the Iowa State CP Tech Center, and Doug was involved in these, where he went out, he and Scott Schlorholtz went out and looked at 26 different sites which had different levels of slag, and they did an analysis of how those sites performed, and actually they did quite well. The conclusion was that if slag is placed properly, it's not going to scale generally. And then there was a follow-on study called Evaluation of Different Laboratory Scaling Test Methods, where I think the outcome of that was essentially a proposal that would be an alternative to ASTM C672, particularly when you're using SCMs. And this research has actually come to the fore right now, because we're still getting into salt scaling issues in, say, the northern Midwest area of the U.S., where maybe finishers aren't doing the right thing, and people are thinking, well, it kind of happened during a bad winter after 1L cements were initiated, but they were also using a lot of slag in the mixtures. So, scaling is still a huge issue in certain areas of the country. What I'd like to do is just thank Doug for all this research, for all the help that he's given. Me personally, the Slag Cement Association, many of the cement companies and concrete producers, and for really forming a great deal of the research that's cited in ACI 233. So, Doug, I thank you for all this, and